Welcome to 33rd lecture on numerical analysis. We are studying numerical integration and we'll continue studying Gaussian quadrature rule that we started studying in our last lecture, NA-32. And in NA-32 we studied that f of x integrated from -1 to 1, any f of x with a certain degree of polynomial can be represented as wi's, f of xi's, and their sum from 1 to n. N is a very important number. N is a very important number. For n is equal to 2, the maximum order of the polynomial that this integral can cater for, or this approximation of this integral in fact can cater for, is 2n minus 1. So if you put n is equal to 2, the maximum degree of polynomial that we can expect for f of x should be 3. So this approximation is correct. If we select n is equal to 2, this approximation is correct for polynomials of degree up to 3. They can be less than 3. Therefore we limit to 1 to 2 because we selected n is equal to 2 in our last lecture, and this summation can be expanded like this. In NA-32 we solved 4 linear equations simultaneously. In our last lecture, NA-32, we solved 4 linear equations simultaneously, and this integral integrated from -1 to 1 was written as f of 1 over square root of 3 plus f of minus 1 over square root of 3. Right, and we also solved an example. In this lecture we'll solve another example where f of x is given to be x plus 3x squared plus x cubed. Right, the integral from -1 to 1 f of x, yes, it can be handled using n is equal to 2 because the max degree of polynomial is 3 here. But if it would be 4, we won't be able to handle it using n is equal to 2. That is what we already know. Right, so the maximum degree that we can handle is 3 if we select n is equal to 2. Right, and we first integrated and using the conventional method, and we reached to the exact answer. This 2 is the exact answer. So let's now verify whether the Gauss quadrature method also reaches to the same answer too. Let's verify it, let's check it. Right, so in our last lecture NA-32 we studied, and we proved that any f of x is integrated from -1 to 1 using Gauss quadrature rule can be represented like this. We reached to this conclusion after solving 4 simultaneous equations. And if we plug that here, f of x is this, and if we compute f of 1 over square root of 3, it comes out to be this, and if we compute f of -1 over square root of 3, it comes out to be this. So now we have computed f of 1 over square root of 3 and f of -1 over square root of 3, and as per the formula, if we add those, we reach the same answer. Right, so this means that using the Gaussian quadrature rule we reach to the same answer, the exact answer. So we reach to the exact answer. It is equal to the exact answer. Right, so in our next lecture, that's all for this lecture, and in the next lecture we will study NA-34. We will study how to solve integrals how to solve definite integrals if the limits are not from -1 to 1, they are other than this range. So we'll see how to solve these definite integrals using Gauss quadrature rule if the limits are not from -1 to 1. So we'll see that in our next lecture. Thank you.